Hello, everyone, and welcome to another episode of Simplifying Network Automation with NetGroom. I'm your host, and we're taking a bit of a break today, actually, from Cisco Month of Learning. Well, not a break, but I would say kind of like a sidestep. And we'll be back with the fourth episode next week with Ed Novak and Cisco Workflows, like I was saying also last week. It's because Cisco Workflows actually goes GA. I think it went like yesterday. It goes these days GA. So we wanted to give a bit of time. We'll bring Ed and we'll wrap up the Cisco month of networking next week. But in the meantime, this week we have Patrick Ogenstad. Patrick, I hope I got your last name right. Thank you so much for joining. Um, how are you? How have you been? Tell us a bit about yourself. I know you're working at OpsMill. How's that going?
Yeah, thank you. Yeah, the name is perfect. Yes, I am working as a lead in the backend team at OpsMill, and yeah, I really enjoy that part. So, like, OpsMill was solving a problem that I was thinking about myself for like 6 or 7 years ago. So it kind of felt really exciting to start to work in that capacity. Um, and it's also enabled me to return to like the open source network automation world. So I kind of began to contribute to open source network automation around 10 years ago. Um, at that point, it was when I started to look at like Ansible. So this was before Ansible had any real networking modules of their own. So I started doing tests with like SNMP to use Ansible modules using SNMP to make idempotent changes to network devices. And
Oh,
it kind of worked depending on like what you wanted to do, but
that sounds painful.
it was really painful, and you kind of got a good understanding of why people wanted to avoid SNMP
Hmm.
in general. And I think SNMP also suffered from some of the issues that we'll talk about today, just regarding typing, and like if sometimes you weren't really sure like what the various values were within the SNMP MIBs. And then I've also contributed to Napalm and Nornir, as well as helped like hundreds of people in various network projects, both in online forums and customers. So yeah, that's like quickly
Yeah,
about me.
because I was just looking the other day at Nornir because I'm developing some content around it, and then yeah, I saw your name as a contributor over there. So it's like, this is gonna be excited. I have Patrick on the live stream. So fantastic. So then at OpsMill, right, like you were saying, solving a problem, and that's around InfraHub, right? And the product that you and the team are building. We've talked about this. We've had a couple of sessions with Damien Garros. Um, and tell us a bit about that. It's like InfraHub from your perspective.
Yeah, so what InfraHub does is that it's a source of truth application where
Hmm.
you store data related to infrastructure. And the unique part of it is that it doesn't come with a predefined schema. So instead, each organization would pretty much define what their data model would look like. So you load a schema that consists of a number of nodes that have attributes and relationships to other nodes. So instead of having a generic networking model, you can pretty much define your own model. The other part of the solution is that we support branching. So it kind of works in a similar way as you would have branches in Git, where you can check out the branch, make changes within that branch, and then after seeing a pipeline complete, you can merge the changes back into the like production branch that you're using. And that specifically was the problem that I was looking at all those years ago. So when you are planning a change for big, I was working in an ISP at the time, and when you're planning like a big migration, you don't want to make changes to the network monitoring system, the documentation for the network, and all of these other tools like leading up to the change, since you want everything to be synced when you are actually like you want everything to be synced as it is within production, but there are so many changes that could need to be made, so it's hard to do like with any non-custom application
Mm-hmm.
if you can't do it within a branch. So like that was the like selling point for me when I was joining OpsMill. And then we have a number of other features like to generate configuration artifacts or just like render larger uh, larger networks using the business logic of our customers together with just the ability for them to define how they want to like organize data within the product.
Yeah, so Damien, yeah, pretty much was showing exactly what you were saying, and we'll bring Damien back also on the stream. He'll be coming to talk a bit more about the InfraHub API and SDK, Python SDK specifically. So we'll address that too. Cool. So let me ask you this then. Are you originally a network engineer, or have you been like a software developer from the beginning, or you transitioned at some point from one to the other?
I think that's something I like about this industry. So like I've been working in it for so long, and then even if at the previous job I had, I stayed there for years and years and years. But working there, I had a number of different roles. So initially, I started out working with like Windows NT and
Mm.
Linux and Unix, and then from there, I transitioned into networking and security, and then more into automation, and then um, more and more into pure development. But the development aspect has been like a huge interest from the beginning. And I wrote my first lines of code when I was probably 10 or 11, when we found like within an English textbook, there was just a small screenshot of some quick basic commands. And it was like, well, what's that? And yeah, try to kind of figure out how that part was working. Um, and luckily at that point, it wasn't that easy to like find information for like when I want to take the next step, how to actually do that. It's like today you have internet, YouTube, chat GPT to coach you. Like it's so easy to learn stuff these days. So yeah, but I continued that approach. Like it took a few years after the initial tests, and then I've been trying a number of different languages until I arrived at Python.
Gotcha. Yeah, I remember those days, right, on the early internet when you were looking for something or looking for books because information was not readily available like it is today. But it was, in a way, more rewarding when you found what you were looking for, right? Because it took you longer to find it. But once you found it, it's like, oh man, I got it. So it's like you were so
Yeah,
happy.
definitely.
And now, everything is at the tip of your fingers and you can find everything in a split second. And I
Mm.
think people have become complacent or something because it's just like too easy now to find everything, or you're just too much information out there. You're being bombarded by too much stuff.
Mm. Yeah, or I guess that it's just so much to learn. Like
Mm,
if you look back at learning networking and like systems for 20 years or 25 years, and like in the beginning, you didn't know how DNS worked, you didn't know how VLANs work or how IP addresses worked, and then like coming into it without any prior knowledge, like there's a huge amount of things that you just need to become familiar with. Docker these days and
mm.
AI.
Yeah, it's another aspect because everything changes all the time. So it keeps us on our toes for sure. Have to keep up to date with everything. And talking about that, right? So
Yes.
Python typing, you're a Python developer. Is that your favorite language, Patrick? Let me ask you that. Python or
It's definitely the language that I'm using most. So I mean, I would say there are a few things that I don't really like about Python. That I wished it was a bit more strict than it is. Like
Mhm.
when I started using Python, I like the flexibility and the ability to basically do everything. But when I've started as I've started to work on larger projects, I think like there are a number of things that I would want them to be different, and typing is one of those issues. So like it's quite easy when you go into a new project if you just enable the strictest mode possible, you can kind of keep it that way. But if you don't have it from the beginning, then it can take quite a lot of effort to kind of polish it up and to fix it. And typically, those aren't the tasks that are rewarded by an organization. Like you typically want to develop new features and things like that. Um, Another issue I have with Python is the error handling. Like I don't really like how errors are handled, where the typical convention is that you shouldn't catch errors that are too broad. But at the same time, I don't think that Python has a great way to indicate when an error might happen. So like just opening a file, like there can be so many things that can go wrong. It could be that the file doesn't exist. You don't have permissions to the file. When you open it, it might be in the wrong format. And then like uh, the best approach, if you follow the pedantic way, would be to kind of catch all of the different error types. Or if you connect to um, an HTTP, like an API, it could be that the network is down, the certificate is invalid, like a number of things that can go wrong. And sometimes I think it can be good to catch broad errors just to kind of see. Um, yeah,
so then would you think like maybe Go would uh, did they address some of those concerns or some of those issues, right? I think.
yeah. I mean, in that case, both of them are kind of built into how the language works. In its core. And of course, Rust would be the same, but
Mhm.
I think of those two, Go is a lot easier to work with, and like um, the way uh, you have to manage variables in Rust is so different from many other languages. But I mean, even if I, to some degree, would prefer working more with Golang, like Python is so
Pervasive
uh,
and is
uh,
everywhere, right?
yeah,
Like
and especially in the networking industry, like yeah, it's really popular here. So
definitely, yeah. Everybody has their SDKs in Python first and foremost, right? Um,
mm,
we're teaching Python. There's Python courses for network engineers out there.
mm,
So yes, at least to get started with automation, it seems like the whole industry is pointing people towards Python, right? And then once you get into it, like you have, and then you find the limitations when you try to scale it or go to larger projects, then you start looking. It's like, okay, so what else is out there?
mm,
Um,
yeah. Yeah, and I mean, depending on what you do, like it might be that you never run into any real um, limitations, or if you're working
mhm.
with some APIs and connecting various network controllers, like it could be that you never need anything else, and everything works out perfectly well. Like one of the early stories I heard about Python was for YouTube. So YouTube were competing against Google Video, which was YouTube wasn't owned by Google at that time, and then YouTube were pushing out features at a lot faster pace than Google Video. And the strange thing was that YouTube had 20 developers, whereas Google Video had hundreds of developers. But YouTube was written in Python, whereas Google Video was written in C++. So like just the ability to move fast is also very appealing.
Mm-hmm. All right. So yeah, sorry. Go ahead.
Yeah, I mean, perhaps we should jump into the.
Yeah. So let's talk about typing, right?
Yes.
And tell us a bit about your experience with it, because I know it's a very important topic to discuss, especially for like a code maintainability perspective. So yeah, let's have a look. I know you have some code for us.
Yeah, I can go ahead and share my screen, and it might be easier to talk about it while we have this open.
There we go.
So Python. So what separates Python from other or many other languages is that Python is dynamically typed, which means that you don't need to define the value of variables or input parameters, or like what a function will return. And in this editor, we see that like for this simple function that basically takes 2 arguments and returns the names using the title form, we don't really know what to send into this function. And that's really the main issue with when you have this dynamic that dynamic typing. So luckily in this case, we have this docstring, which provides some kind of help for users so they can see that, well, the arguments should be 2 strings and it will also return a string. And having something like this has for a long time been a recommendation for Python, that you will have a docstring for your public functions. And then one problem is that there's like multiple variations of how you can actually format this docstring, and there are like different styles for how you might do it. But at some point, people figured out that like it would be good if Python, even if it's a dynamically typed language,
If we put some
we can.
guardrails around that, right? Yeah.
Yeah, exactly. To kind of help the developers, and even like I think it was in Python 3.5 that we started to see the first iteration of this. And these days, most people are editing their code using a language server, which kind of understands your code and can provide feedback. So one immediate benefit of using typing is that you can assist the editor to understand your code. And the way we see that here is that if we look at these first name and last name, if we know a bit of Python, we know that the string will have a function called title, which will change the string so that the first letter is in uppercase and all of the others are in lowercase. But in this case, it's grayed out in the editor, meaning that the editor doesn't know what this is. And the reason is basically that there's no type for this. So having a type would basically mean that we have a colon, and then after that we have an indicator of the type. So if we basically rewrite this to show it as it would look by default is that we have a username that can be anything, a last name that can be anything, and then we don't really know what it will return, or what this function will return. And I will remove the doc string just so we can see it all on the screen. So, and in this case, it will pretty much work the same way as before, but there's no additional help. So if we instead change this so that we say that this is an integer, then we immediately say that, wait a minute, this is something is wrong here, because we're expecting last name to have this function called title, but the editor or the language server knows that an integer won't have this this function. And that's something that would be picked up if we kind of analyzed the code using a type checker. So the correct format here would be like this. So we know that we expect a string for first name and last name, and then the function will return a string, and then we don't really care about this part. And of course, if we check down here, we see that, well, here we actually have a problem which didn't appear previously. And if we don't have the type annotation for last name, then this can look completely fine, and we wouldn't really see it until we actually try to run this program and we see that, okay, something didn't work correctly. Whereas if we analyze this with what's called a static type checker, we see that, well, it's complaining, and like this is a simple bug, of course, but it kind of highlights something that can come up so often in larger code bases, where you kind of expect something to work in one way, and then you run into bugs that should have been caught by the compiler or by some tests. So what's happening in within Visual Studio Code, we're using the Pylance extension, which in turn uses something called PyWrite to analyze the code. The command line tool that I was running is called MyPy, which has been
I was about to ask, about MyPy, because that's like a static type you said, so looked pretty cool.
Yeah, exactly. So this would be used to run against your project. So you can run it like either from your laptop or from a server, but typically you would tie it to the CI pipeline. So whenever you check in code, MyPy would run through it to see if there are any typing violations that would need to be fixed. And MyPy has been around for a number of years now, and we've started to see some other alternatives come up. So Pyre is another one that I think it's Facebook that created it, if I'm not mistaken. And it is a lot faster than MyPy is. So it's written in Rust, which makes just the processing a lot faster. I haven't actually tried this that much, and I'm kind of waiting for this new alternative to be more mature. So Ty is from the Astral project that also created Rough, which is another kind of linting tool for Python, also written in Rust. And I think like when this becomes mature enough, I will migrate to this from MyPy, but I probably won't do much with this Pyre until until it's more mature. So this is just kind of the first basic parts of like what it is we would be expected to do when we start to add types to a Python file. If we start to dig in a bit more, we have another example here, which it pretty much does the same thing, only this time we have a few more functions. We have the show all names function, which will issue kind of the previous function we had, as well as a new function that outputs names based on a Python dictionary. And I think a raw dictionary like this can pose quite a few problems. Something that I think about is like this old line from Forrest Gump, the movie from the 90s, where he says that life is like a box of chocolate. You never know what you're going to get.
Exactly. Dictionary, what type of data you have in that dictionary, right?
Yeah, and like it can really be anything. If we run this code coming out these lines, we will get something that that works, but it's easy to hide other issues here. So what we typically want, like if we can perhaps just start. Sorry.
And do a MyPy on it, yeah.
Yes.
Let's see the type checker.
So here it's basically complaining that, wait a minute, you have a an untyped dictionary. So even though we have typing as part of our function, MyPy doesn't like this. And the reason is that, well, we, as we said, it could be anything. So one way to correct this is that, well, we want to have a dictionary of strings containing strings, which means that the keys would be strings and the values would be strings, which matches what we have here. So first name would be the key, and then Steve the value, and last name another key, and Rogers a value. And this would help us just if we look at what we currently have, and it will also work. And then if we...
And MyPy is happy.
MyPy is happy in this case. However, if we introduce something else, then it should complain, saying that, okay, now we're sending this dictionary object to person, but it looks like we have some kind of error here. And the reason is that now we don't have a dictionary of strings and strings anymore, since we have the age field. So what can we do then? One way would be to say that, okay, we have the string here, and then optionally it can also be an integer, which would fulfill like what this dictionary looks like. The problem, of course, becomes apparent here that, okay, well, this seems wrong, because now we kind of assume that first name could be either a string or an integer, and we want something else. So what many people end up with is like, okay, let's just import this any guy again. So,
import, yeah.
And then there, we have solved it. And if we look in MyPy, it can be it can be accepted depending on the configuration. So by default, this would be allowed, but here it's specifically set to warn against that. And the problem, if we allow something like this, is that if we continue with the last example and we run the script, then we see now we get an error because the key last name is not found. So even though the function itself supports typing, our input data is incorrect. And obviously we can't really use this dict of string and any, and we saw earlier that we can't use the string or an integer.
Mm-hmm.
So one other option that we could use is that from the typing library, there's something called a typed dict, which allows you to create the kind of custom dictionary. That contains a few fields. So we will have the first name and last name, and then age, which is an integer. And then instead of this function accepting a dictionary, we will use
class, an instantiation of the class.
Yeah, exactly. And this part would still be problematic, but if we say that, okay, now we want this to be a list of persons, now we see the actual error we had previously, like, okay, well, you can't, we can't have the surname here, so we have to change it. And now we still get an error. So, okay, well, what's the problem now?
The error just exploded. Now everything is errored.
Yeah, and I think like this can be a reason why a lot of people kind of start to look at typing, and you start to do something, and it's like, okay, well, you kind of start to ask yourself, like, what value was it that I was actually getting out of this from the first place? And the problem here is that, okay, we have age, and within our definition of this type dictionary, age would be required, a required key within the dictionary, whereas we have a few of the entries in our list that doesn't contain this. So we need to indicate that it isn't required. So yeah, now it should be quite good.
Mm-hmm.
And if we then run MyPy, it shouldn't complain about anything. And if we look at like what you need to do when you're starting out with this, if we just open a fresh file and then try to run MyPy on this, we see that, okay, we have a number of issues, and then the best place to start would have, of course, have been like when you created the project. But if you want to introduce this into an existing project, I would first just enable it. Like if we have this pyproject.toml file, we install MyPy in the project and set up the kind of initial rules, and then just try to run it, and then check to see like what errors do we have within the project, and we can either disable error codes at the global level or individually, like on a specific file. So if we go back to the error we have from this file, we see that, okay, we have function is missing type annotations for one or more arguments for a function. And then we see call to untyped function, which basically means that, okay, we have at least one function that has incomplete type annotations. And we are also calling this function from a number of places. And if you're starting out, it could be like, okay, we know that we have functions that have missing type annotations. So perhaps we can start by ignoring calls to the untyped type annotations. So we will update the rule set to ignore those in this file. And going back to MyPy, we say that, okay, now it looks easier. There are like less things that we need to fix, and I think like this would be a good approach in terms of limiting what you need to do when you're setting out. And instead of fixing everything, a goal could at least be to avoid introducing new errors. So start out small and just kind of work your way through it.
So then, Patrick, right? As you show types, what would be some of the best practices, right? As you start writing code from your experience, do you make Python like a strongly typed language using this type, or at least you're trying to? Like, what should people do?
Yeah, I mean, so one thing is that these are, if we look at the code, so all of these are what's called type hints. So Python, even with these in place, Python won't enforce anything. So it's somewhat of a gentleman's agreement where we say it's a string, and we have validations running with MyPy or another type checker to validate that what we're sending in or what we're doing with the returned value from the functions or methods matches up with our expectations.
But that's just like a nice to have, or it's we tell it that it's a string, but that's it. We're not, like you said, enforcing it.
No, we're not enforcing it. So the what we need to do basically is to have type checking running on all of the parts of the code. So within the code, that part would be simple to do. Like that's the part we have control over, and then we need to look at what's incoming into this application from other locations. So if you're targeting a networking API, you probably need to validate that the response that you're getting from the API matches up with your expectations before sending it off somewhere else as a pure Python dictionary. So if we are getting data from an API and just converting it to Python dictionary internally and then sending it off to our other functions, then that in itself could be problematic, since it kind of requires us to do additional validations. So in that case, I would use like either data classes, or if we use Pydantic, we can validate that the thing we're getting from this external service matches up with what we expect to see And if not, we raise an error at that stage instead of having it kind of traverse all of our code until we reach somewhere where things doesn't work.
Okay, because I mean, yeah, this could get complicated troubleshooting this, right? As there's a snowball effect to it because you're missing a type somewhere and then it affects a different function. So you have to kind of look through the whole code and figure out where. And with MyPy, with the type checker, that helps. But
Mm.
um, yeah, I could see this getting out of control for especially larger projects.
Mm. Yeah, for sure, and definitely, like if the error happens a few function calls later on, um, you need to track like where did this originate from,
Mm-hmm.
and that's something that you can avoid if you have more strict type checking.
Mm-hmm.
Um, but even then, like it's going to depend on like that there are so many um, violations, if you will, that you can do within the Python code base to kind of avoid avoid um, following the guidelines, or if you're updating an object after it has been created, um, like the a lot of a lot of the validation would happen during assignment, and then if you modify something after the fact, it could be that you end up in some weird situation. But type checking would manage or find most of those issues, at least.
Gotcha. So let's have a question here, right? You were saying an API, you access an API for a device, whatever it is, right, over REST, and you get your JSON payload back, whatever get call you're doing or whatever it is. So how would be a best practice of handling that JSON payload that you get back, right?
Mm.
How would you type check that JSON output?
I would probably use something like Pydantic.
Okay.
Um, so if we add that quickly, um, so Pydantic enables you to create custom classes. So let's um, I don't know.
Uh, firewall, yeah, whatever. IP address, right? Port, number, whatever it is. Yeah.
Yeah. Um, IP address. And if it's an IP address, perhaps we don't want a string. Perhaps we want.
A special format for the IP address, right? You have like if it's IPv4 or IPv6,
Mm,
you have to create a different data model basically for that.
yeah, exactly. So like it could be that you have something like this. So then we would have a firewall class here that would kind of be follow the structure of the API that you're using, um, and then as you are loading the data from the
The
uh,
response you basically would declare it as this class type, right?
yeah, or you would like create an object of this class, and
Mm-hmm.
then that would fail if the response didn't match up with what we were seeing. So if we
And you'd be able also, yes, to catch API changes, right? So if something changes in the API with a new version or something, if you define your class initially, right, and the response in version of the future version of the API differs from the class that you've defined, then you can catch it pretty much instantaneously. Hey, the response has changed, doesn't match the class type that you have defined, and you can start troubleshooting pretty much instantaneously. Then, letting it go within your code, which function is going to get called, you lose track of it. But yes, I agree. If you define your class, you make the response of that type of class instantiated basically, then you can catch very quick if any changes in the API. It's a good one.
Mm. And then of course, like you might argue, like, well, okay, well then I might get a failure just when I'm loading the data from the API. But of course, you would get the failure anyway. It's just going to happen later. So it's better if we can
Catch it
if
this
we
the
can
earlier
catch.
as possible. Yeah.
Yeah, exactly. So I think my screen did something weird, but basically we have a dictionary that would look like this, and then using Pydantic we can load the data into an object, and then, or perhaps, yeah, something like this. So now we have that firewall response that have a name and an IP address, and then you would use this object type within your function definitions as part of the type hints, and then MyPy would also complain if you're trying to send in something else to that function. So that way you can kind of track if you have external data coming into your system.
Makes sense. All right, so that's how you would handle responses. What about how you send data, right? So let's say we're doing a post call, and it's pretty much similar, right? You would define the body of your call as a different class.
Mm. Yeah, I would say it would be exactly the same thing. And then, of course, you would have to have your definition up to date with regards to what you're sending to the other side. So if you're using an SDK of some sort for that other service, then hopefully that should be up to date. But depending on what it is, like it could be that your version is out of date, or like something has changed on the other side. But definitely that would be the way to do it. Yes.
All right, that makes sense. I see here you have more. So we've
Yes.
covered quite a bit of content so far, but then you have attributes. Yes.
Yeah, we can see how far we get for this. But another issue is like we've looked at the input parameters for functions as well as the return data for functions, but of course it doesn't end with the function definitions themselves. So in this case, we have this data class, which is a simple way to create a custom class in Python, where it kind of removes some of the boilerplate that's needed to initialize an object. And here we have the person that would take a first name, last name, an optional middle name, and then a birth year. But then we also have this age property, which will try to determine the age of the person depending on the birth year. And here we also see that I've probably had some issue with this before, because I've added this comment to like ignore typing on this line. And this is also something you can see quite a lot in different code bases, where instead of solving the problem, we ignore it, perhaps for now. Like we'll get to fixing this at some point. And if we look at this function and try to run it, Okay, now I was still in my old Python shell. If we run it, we see that, okay, it completes successfully, and based on the years, it looks great. But then we go back here, and then we realize that, okay, I actually got this from ChatGPT, so I don't know if it's correct. I will remove that part, and then when we run it again, of course, it will fail. And depending on where this came from, like it could be a huge problem. And in this case, of course, MyPy wouldn't catch this because we've opted to ignore the error completely. So the better approach would be to, well, I don't know what happened here. The better approach would be to avoid these type of ignores. Sorry, I don't really know what I'm doing now. And review, like, what is it that we actually want here. In this case, the correct approach would probably be to raise some kind of error if you asked for the age, or perhaps birth year should be mandatory, so that we have to supply it when we are creating the persons of this class. So some other recommendations is that when we define the parameters and the return values, we want them to be as broad as possible for the values that we accept, and as narrow as possible for the values that we return. So then there's this kind of, in plain English, where we should be as liberal in what we accept, and as conservative as in terms of what we send back from our functions. And in this case, we're kind of mixing the format name function we had previously with this strip items function that will basically remove the white space from a list and return the list. And what we might see here is that if we look at the lists, we see that, okay, in this case, we're returning or accepting a list of strings, and we are returning a list of strings. But if we look at this actual function, we see that in theory, we would be able to use this function for other purposes as well. It wouldn't. We can accept other things than just a list. So an example would be like if we instead want tuple, then we see that this
my tuple, yeah.
Yes. It's complaining here because we're trying to send in a tuple to the function that
takes in as strings,
takes a string or list of strings. But if we run it, like, the Python isn't really complaining about anything. So what we could do instead is that instead of defining a list like this, we can use from we can say that it's enough that this is just an iterable there. And now the typing would be accepted for the tuple as well. And the same thing for the other function, format name. So in this case, we say that this should be a string, but the real requirement really is that we want to have this title function that we need to call. And in this case, the example I'll show might be a bit like convoluted, but what we can do if we want our functions to accept the behavior instead of a given type is that we can import from we import protocol, and then we need to create a new class.
Mm-hmm.
So now we have what's called a protocol, and the protocol defines any class that has this title function. And just by using this, we can replace the string here and say that now we will accept string, since string has the title function, but perhaps our data class should also have one of those. And then we can say that now in this case we can send in both a string or a class that has this title function. So typically this might be that you have some kind of device that has a save function or a commit function, and you want to treat different devices in the same way using your function.
Mm-hmm.
One other quick thing, I see we're kind of running out of time, but if we look at this file where we are importing third-party packages or something that isn't included in Python, we have two packages that both would operate with HTTP requests. But if we run, so just looking at this, everything looks fine here. But if we run MyPy here, we see that, well, it's complaining because it doesn't really understand this requests library that we're using. And it also says that we can install stub packages for this. And the reason for that is that if we look at this package, we see that if we start with one that works, so HTTPX, if we look within the source in GitHub, we see that this package has a file called py.typed, which is used by external packages you use to indicate that within this project, we're using a typed environment. So when you use this project within, or this package within your code, the typing will behave as expected. Whereas within the requests package, we don't have that file here. So within requests, you can still, or for requests specifically, you can install this package called types-requests in order to have them enabled. So one thing to keep in mind specifically for something like this is that since this will only be used for type checking, the best option would be if you're using a package manager like UV or Python Poetry, that you install it as a development dependency instead of having it as a main dependency for your project. So basically, we will have a separation with regards to the development or the dependencies of the project itself, or anything that's only used for development. I had one more thing to show. I don't know if
yeah, Yeah, let's wrap it up then. Yeah.
Yeah. So another thing is a situation here where we have a function that will read files, and one file is a text file and the other file is a binary file, which means that we need to read them in different ways. But we have this old function called read file, which will basically just have a flag to indicate if it should read a file in binary way, or if we should just read it as a text file. And running this, the binary file produces a kind of weird output, but everything works. But the undesired part here might be that, like, when we look at the returned value here, we see that this function returns either a string or bytes. And since I've written this function, I know that the first one would return bytes, and the text file would return just
Strings, basically.
yeah, string. So what we can do is to kind of help the system a bit. So again, from the typing library, we import a decorator called overload, and then we can have I will actually copy this, it's a bit quicker.
Mm.
So we are overloading this function in two ways, where we basically say that if we are using this function and we are sending in the binary value where it's set to true, then we will return bytes. If we are reading the file and we don't specify anything, or we set it to false, then we will return a string. And now if we look here, we see that the editor knows that, okay, since you did this, then I know that logo would be of type bytes and about would be of type string. So some places where this could be used is like if you're searching for something and you might want to like raise an exception if you don't find it, or it could be that you would want to return the value or none if you don't find it. In the best of worlds, I would probably want to avoid this and avoid functions that can return like multiple type of
Mhm.
values. But I think that this can be a good,
A way
good
to
way to,
address. Yeah, yeah.
yeah, yeah, exactly, a way to address the situation.
Interesting. And then MyPy also probably pass this and not complain anymore, right? It kind of like this. So,
Yes, it should at least.
oh, it still doesn't.
Okay, yeah, it's because the file object itself doesn't.
Have a read method.
Yeah, so the read method returns an any here. So yeah, that would be something that we would need to address for sure.
Mm. All right, Patrick. Well, this is very interesting. I don't know about MyPy. At least I discovered that personally. Okay, so static type checker with MyPy, pretty much have it as part of your pipeline, or like you said, right? You want to have whenever you're submitting code or anything, make sure you run a type checker as part of pretty much your initial checks on the code, right? You want that step to be done as soon as possible, because like you've shown, right, the code could run, but it could hide, these issues within it for you.
Mm,
And then you start troubleshooting and you run into all types of issues. So making sure you have your types defined and a static checker like MyPy just run through your code, because you want to catch these situations as early as possible. If not, you'll have bugs, right? It's pretty much
mm,
guaranteed you get into issues as you write more code.
yeah, and I would say the other thing is just that it's going to help you when you are working with the code within your editor. So if you have types, then you get like command completion and integrated help for all of the objects that you're working with, instead of having these kind of grayed out lines where the editor doesn't really know what's going
Hmm.
on.
Exactly. All right. Well, thank you so much for showing us Python typing and best practices around it. Really appreciate it. Any final words, Patrick, before we wrap this up?
No, thanks for having me. Yeah, like if you haven't tested it out in your project, at least like enable it and run it and see what happens. Like what does it complain about, and
Hmm.
yeah, think about your code and any areas that might be problematic, or that might be some parts where you kind of know that you have ignored something.
Perfect. Well, thank you so much again. Best practices for Python code, folks. As you start writing, developing, make sure you check your types, you define them. Thank you all for watching. Thanks all for being here. Patrick, thanks again. And remember, folks, see you next week. Like we've said, we're going to wrap up the Cisco month of networking learning with Ed Novak and Cisco workflows. So we'll have a look at that. And yeah, thank you all for watching. See you in the next one. Patrick, thanks.
Thank you.